This application of anagrams is an example from the homework problems from chapter 2 in the book. This is number 28 in Brualdi. But it's also an application of combinations in general. And it's network routing, which for any network, choosing paths through that network is important. Knowing how many options there are is important, with perhaps some constraints. For instance, just sending an email, it has to be chosen what path the packets of information will take through the internet. So here's the example from the book. Now they put it in terms of choosing a way to walk from home to work. But of course those nodes could be computers in a network too. And they give you this example of a grid network. It's 9 by 8 blocks. That means if you count the dots on the horizontal, there will be 10 dots. They go from dot 0 to dot 9, but there will be 9 connections connecting horizontal segments. And similarly for the vertical, there will be 8 segments that go from 0 to 8. The dots go from 0 to 8. Okay, so starting at home, going to work, you're forced to go north and east. You can't go west or south. And that's the same as positive y or positive x. We could use the points here just like they're points on the xy graph. All right, so first off, it asks how many ways can you get from home to work? So I highlighted one path there from node 0, 0 to node 9, 8. And here's the highlighted path. It goes east, east, north, 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 and so on. You can check that I have the east and north steps in order. Well, here's the way that you answer it. You notice looking at that path that there are exactly 9 e's and 8 n's. You're always going to have to go 9 east and 8 north in any path, in any order that you take. So every path corresponds exactly to just a rearrangement of that list of east and north steps. You might have to think about that for a few minutes, seconds maybe. You always have to take 9 steps east and 8 steps north, and it won't matter which order you take them. You could do all east first and then all 8 north steps. All we have to do is choose which of the 17 blocks that you step, because there's 17 total, 9 plus 8, will be east. So the answer is 17, choose 9. Which is the same thing as the number of anagrams of that list of e's and n's. 17 places. We could you could do a 17 factorial divided by 9 factorial, 8 factorial. Because remember, 17 choose 9 is the same thing as 17 choose 8. Yeah, 17. Ooh, that's supposed to be a factorial. I'll fix that on the file. 17 factorial divided by 8 factorial, 9 factorial. And that comes out to 24,310. Now, next question. How many routes are there if the block W is underwater and cannot be used? The block W starts at 4, 3 and goes to 5, 3. I redrew it here. So this is where you have a constraint that you can't use that connection. So then look at the red box and the blue box. The idea is that those show all the illegal routes where you end up at the beginning of W, you use W, and then you go from there to the finish. So the big W starts at 4, 3 and it ends at 5, 3. So here's the answer. Start out with the total number of routes, 17 choose 9. Then subtract the illegal ones. Now to find the illegal ones, you do 7 choose 4 to get to the beginning of W. That's because there's 7 steps to get there and 4 east steps. Then 1 choose 1 I just put in as a way of crossing W. It could be more complicated, but this time it's just one way to do it. And then 9 choose 4 is to go from the end of W to the finish, 9 comma 8. So then you subtract those two to get the final answer.